So what do we understand by cybercrime? So quickly, just let me give a brief introduction about all these terms. So cybercrimes are any sort of crime which is committed with the use of computers, internet, or any other digital medium. Either it can be used as a tool or it can be used as a target, right? See why it is used computer, internet, or any other digital medium, because nowadays your digital medium is not limited to your computers or mobile phones or internet, right? Nowadays the IoT devices are also there, those devices which are actually not meant to connect with the internet, but still they are connected, like for example your smart TVs, smart refrigerators, smart ACs, smart washing machines, all those devices are considered as IoT devices. If crime is being committed on those devices, that can also be considered under the cybercrime, right? It can be used as a tool as well as it can be used as a target. How it can be used as a tool? So you see, when digital medium is only used as a tool, right? For example, I am given instruction that you have to commit crime at this particular space and at this particular time. So the mode of instruction is in the digital medium, right? So you can say cyber world is being used as a tool, and how it can be used as a target in such conditions where crime is being committed on that particular device. We can say it is used as a target, right? Or it can be used as a tool. So what do we understand by cyber forensics? So we see forensic science is the application of science for the purpose of fraud. Right. Whenever you find that any legal matter occurs, the analysis part with scientific aid is being done by forensic science. Right. So that's why we are calling it as application of sciences for the purpose of law. Right. What is the process of forensic? It is the identifying, collecting, preserving, analyzing, and presenting the digital evidence in such a manner that it is acceptable in the court of law, right? But here in the cyber forensics, we are dealing with digital evidences, right? So what are the different branches of digital forensics? You see, there are certain computer forensics, mobile device forensics, network forensics, email and social media forensics, and database forensics. In the computer forensics, we are mainly dealing with various operating systems like your Windows, Linux, Mac OS. In mobile device forensics, we are mainly, see, it is not limited to mobile phones, right? Mobile is a property. Mobile is all such devices which is movable, which is portable. We can say it as a mobile device, right? Like your smart watch, that is also mobile device. Your PDA devices, personal device assistants, your separate GPS device is coming. So all such devices are being considered as mobile device forensics. Even your laptop is also mobile device, but that analysis has been carried out in computer forensics because the analysis part of both the devices are same. Network forensics, we are dealing with all such malicious packets which is sent and received within the network, and such intrusion and attack of such intrusion, DOS, DDoS attack, all such packet analysis has been carried out in network forensics. Then we have email and social media forensics, where we are dealing with identifying the person who sends that mail, whether it is legitimate or not, and with and what is the content of the particular email, right? As well as in the social media analysis, we are mainly dealing with the fake profiles and cyberbullying and all such cases. Database forensics, wherein we are also considering cloud, right? All such analysis has been carried out in that particular part, right? So as in digital forensics, we have to deal with digital evidence, right? So what is digital evidence? So we can say digital evidence is any information or data, definitely that should be related to the case, which is stored, received, or transmitted by electronic device, and that must be relied in the court of law, right? Your storage devices is storing your digital evidence. You have a mobile phone, and on your WhatsApp you are receiving that data, right? So it means that you have received, that can also be used as an evidence. And if it is only transmitted, right, here the role of ISP will come into play. Right? ISP is internet service provider, which is only transmitting your data, right? Which is working as an intermediary between user and server, which will take request from the user, send it to server, and again take response from server and send it to the user, right? So it is only transmitting your data. So that transmitted data can also be used as a digital evidence, right? So what are the properties of digital evidence? How it differs from different other source of evidences? We can say it can be duplicated exactly, and copy can be examined as if it will be original, right? We know there are certain ways by which we can duplicate our evidence, our digital evidence, right? There is a process of imaging which frequently we are doing in the forensics. there is a process of cloning as well as we can directly copy and paste our evidence, right? So we can create exact replica of our evidence, which is not possible with any other source of evidence, either it is physical evidence, biological evidence, chemical evidence, whatever. Right? Examining copy will avoid risk of damaging the original. Yes, definitely. With the right tools, it is very easy to determine if digital evidence has been modified or tempered by comparing with the original. Right? You might be aware about the term hash value. Right? So hash value is the only means by which we can verify the integrity of that evidence. Right? If hash value is matching, then definitely we can say that yes, this data is not been tempered. It is relatively difficult to destroy. Yes, definitely we know, because deleted data and you can say formatted data can be recovered with the use of certain tools. Right? When criminals attempt to destroy digital evidence, copies can remain in places even they were not aware of. Right? That we are going to see in the practical part of Windows forensics. Okay, so different type of digital evidence. One is volatile data, non-volatile data. Right? I'll just quickly go through these slides, and after that we'll move to the practical that I am intended to show to this class. Right? So non-volatile data are those data which will remain intact even if the computer gets turned off. Right? For example, your data storages like your hard drives, flash drives, CD, DVDs, all these things. Volatile data are those data which would be lost when your computer gets turned off, right? For example, your temporary files, unset files, or you can say those data which were stored in your RAM, right? So those will your RAM will be wiped out when your computer gets turned off. Sometimes people get misconcept that mobile devices, hard drives, computers are digital evidences. No, see, they are not digital evidence. They are not found in the digital form. They are itself electronic evidences, or we can say they are itself physical evidence which contains digital evidence. So they can be a source of digital evidence. They itself cannot be digital evidence. Right? So what could be the source of digital evidence? Hard drives of your desktop, laptop, external servers, and whatever it is. Flash drives, SD cards, your micro SD cards, and your normal SD cards. Floppy disks. Nowadays we are not finding floppy disks, but sometime you may encounter with floppy disk. RAIDs, redundant array of independent disk, which has been implemented in servers mainly for data redundancies, optical media, CCTVs, where data has been stored in DVR, internal storage of mobile devices, GPS. Why GPS? Because there is a separate GPS device coming in the car, which will work without internet. Pulse side tracks, or you can say tower dumps, and RAM. Okay, so there can be certain various you can say innovative type of source of digital evidence may found, which you must look when you reach to the crime scene in terms of acquiring evidences, right? So there can be USB cookies, USB teddy bear, USB toys, USB cock, whatever you see when you reach to the crime scene, you must look for such evidences. Okay. So what is the process of digital forensic? First, you reach to the crime scene, you have to identify that evidence, you have to preserve and collect that evidence in the forensically sound manner. After coming to the forensic lab, you have to start your analysis on the imaging part, and you have to create a report of that evidence. Right? So these are the steps that you have to follow when you reach to the crime scene. I'll just skip this part, otherwise we'll uh, lose our time in this slides and we'll miss that practical parts that I want to show you. Okay, so these are the tools and equipments that you must have when you reach to the crime scene curing tapes and digital cameras, blank sterile devices, right blocker devices, and everything. Anti-static and anti-magnetic bag, that is Faraday bag. Normally your electronic evidences have been collected in Faraday bag only, right? The reason being it is anti-static as well as anti-magnetic bag, right? You see, that is also been considered as an anti-forensic technique, wherein there is a hard drive, and if it comes into the contact of heavy magnet, your data will be wiped out, right? Because your data in the hard drive has been stored using magnetic field, right? So if heavy magnet comes into the contact of your hard drive, data can be wiped out or data can be erased, right? So to avoid those risks, we are using Faraday bag only. Then we must have toolkits, rubber gloves, some softwares for incident response and collecting volatile data. Okay, so you see this is the right blocker device that you can see here that we can use for creating an image file. This is our batteries and everything. This is the Faraday bell wherein we are collecting our electronic evidences, and these are the converters. Okay. When you reach to the crime scene, you must look for non-electronic evidences also, right? For example, some written passwords or handwritten notes. So many people is having habit to write that password on some cheats and everything, right? So if it is found at the scene of crime, you should collect those things also. Some graphics and some printouts. I'm not sure whether you are aware or not, but there is a concept called yellow dot concept, by which analyzing that yellow dot, that is a particular marking or you can say particular identity of individual printer, right, which has been left over in every printout by that particular printer. Okay, that can be visible, that can be seen under the UV light only, right? In naked eye you cannot see that. Using UV light you can see that yellow dot feature, right? That is a kind of watermark which has been imprinted by every printer on a particular printout, right? So by comparing that printouts, you can get to know which printer is used to print this particular printout. Okay, so that can also be a crucial evidence for you. Okay, so let's start with our demonstration. So first of all, you have to collect your data from scene of crime, right? Let's consider two scenarios. You reach to the crime scene and you find that the system is in the running state. And what you will do, first and foremost thing is to acquire RAM, or you can say volatile data. Okay, so how you can acquire volatile data from the system? There are so many tools available to acquire volatile data from the system, and uh, so there are certain tools which is available in the market that you can use to acquire volatile data. See, there are certain parameters that should be considered when you are going to acquire RAM, right? For example, tool should be portable. If the tool is not portable, if you need to install that particular tool on the suspected system, it will change so many things on that system, right? Which is particularly not acceptable in terms of examination, right? Okay, so this magnet RAM capture, which is portable, so I'll just run it as an admin privileges. All these tools are freely available. I cannot use that word is open source, right? There is a difference between open source and freeware tools, right? These tools are freeware tools which is coming under general public license user, right? You see, this is end user license agreement, right? So this is freely available, but source code of these tools are not publicly available, right? So I'll just click on I accept, and as soon as I click on browse where I want to save my data, so for example, I'll save it on my desktop and I'll give it as sample, right? And I'll click on save. Okay, so I'll give some random name as abcd.raw, and as soon as I click on start, it will start acquiring memory from the system, right? Definitely I'm not going to click on start because it will take some time. Otherwise, to use these tools is very easy. As soon as I click on start, it will start acquiring all volatile data from my system, right? There are other tools also like this dump it. See, dump it is also freely available. You just need to double click on that particular tool, and when you click on that tool, it will ask you whether to continue or not. If you click on Y, it will start acquiring data from that particular system, right? Similar to that, there are other tools also available, like this is the FTK imager, right? This tool is not portable. Okay, FTK imager is not portable. You have to install the particular tool in the target system in during the acquiring of that memory. Okay, so you just click on file, and here the option given is capture memory. So as soon as you select your destination, let's say select on desktop, and it will by default name given is memdump.mem, and if you want to include your page file, it will also include the page file, and if you want to create AD1 file, which is the proprietary file format of access data, you can create. Otherwise you just leave it, and as soon as you click on capture memory, it will start acquiring data from that system. Okay, so this is how you can acquire memory from the running system. There is another tool called Belkasoft, by which this is also a portable tool. You just need to run it with admin privileges, and as soon as you click on capture, it will start acquiring data. As simple as that. Right. So in the second condition, let's consider that your data is your system is turned off. Right. So what you will do? So to create the replica of your evidence, there are three ways by which you can replicate your evidence. One is copy, second one is imaging, and third one is cloning. Right? In a nutshell, I can say what is the basic difference between these three things is, in the copy, whatever data is there in your hard drive, only those data will be copied in your destination. Right? For example, your hard drive capacity is 1 TB, but your data stored is 500 GB. Okay, so in the destination only 500 GB data will be transferred in terms of copy, right? In the imaging, see, the imaging and cloning, both these terms are similar. Okay, I cannot say same, it is similar, wherein every bit is the smallest storage unit of our computer, right? In computers, bit is the smallest unit. So every bit of your hard drive or your storage device will be transferred to the destination in the imaging and cloning both, right? That's why it is also been called as bit stream image. Okay. So what is the difference? In the cloning, it will be exact replica, right? Exact replica means your MBR, your boot sector, your system files, everything will be copied, right? So clone hard drive can be replaced with the original one. Okay, whereas your imaging will be the archived offline copy of your original hard drive. Okay, I'll show you how we can do imaging practically, but you just understand it will be an archived copy of your original data, whereas every bit will be transferred into the destination part, but it cannot be used to replace your original hard drive. Okay, forensically what we are preferring, will prefer imaging only, right? Reason being, there are so many evidences and so many system files available which we cannot access if computer is on, right? Now we have offline copy of our hard drive. In that condition, we can access those system files which contains so many crucial artifacts of Windows operating system, right? I'll show you practically what are those things which we cannot access during system running system, and which we can access if it is in the image form. Okay, so this is copy paste, this cloning, imaging. During the imaging, we must use write blocker devices which prevents writing permissions in your hard drive. You see this screenshot. This is our suspected hard drive. We want to create imaging of this hard drive. We will connect it through this particular write blocker, and through that write blocker, we will connect it to the system. Okay, your workstation. Okay. So how we can create imaging using FTK imager? So you see, this is our FTK imager. You have this option given file, and here we will select our create disk image. Okay, here certain options given: physical drive, logical drive, image file, contents of a folder, and Famico devices. This is for CD DVDs. This is contents of a folder. If you are suspecting that in the entire 1 TB hard drive only these certain files and folders are important and related to the case, we can do that using this option, right? Physical drive means your entire drive, your hard drive or your external pen drive or whatever. Logical drive means your volumes, your C drive, D drive, E drive, and so on. Image file, by image file we are using to create image. So let's say there are certain file formats of your image, right? For example, E01 or Smart or RAW-DD or AFF, whatever. So now we want to convert that image file from RAW-DD to E01, for example. So you can do that using this image file option, right? So just for the example, let me select this physical drive. And here you see it is listed down two hard drives. One is this external hard drive, and second one is this Sony hard drive, right, which is my external USB device. Okay, so I click on finish. So it will ask me where I want to save this evidence. Now you see it has given me four options: RAW-DD, Smart, E01, AFF. Widely these two options have been selected, RAW-DD and E01. Mostly we are selecting E01, which is the proprietary file format of Encase, right? And RAW-DD is the basic file format wherein compression is not available, right? And even it does not contains metadata of your image. Okay, so mostly we are preferring E01, but the basic benefit of RAW-DD is it can be converted in any of the hard drive, any of this evidence type, right? So for example, you want to convert this RAW-DD to E01, it is possible, right? So that's why sometimes we prefer this RAW-DD. You select next. Now you can add your details, case number, evidence number, and all these things. Destination folder where you want to save this, and as soon as you click on finish, it will start acquiring the image. right? I'm not going to do that because it will take some time. This is just for the experiment, right? So let me just add evidence. Okay, so I'll click on file and I'll click on add evidence, and I'll add my C drive, right? I'll add my C drive to extract some of the evidence from this system, right? And just to show you how imaging is more preferable as compared to cloning, right? You see, in the root here you will find artifacts, right? For example, this is the MFT. MFT stands for master file table, right? Which is available in your C drive. Okay, we have added C drive, but you see, if your system is in the running state, in your C drive you will not find those evidences and those artifacts, right? Even if you click on view hidden items, then also that particular $MFT file is not visible, right? $I30 file is not visible, then $log file is not visible. So these are the artifacts which is not visible in your running system. Another thing is, let's say there are certain registry keys, right, which is available into this path. See Windows System 32 config. Right, you see, these are the registry hives, right? This is software system security. These are the registry hives. Now let's say you want to do something and some analysis on this registry hive. So that is not possible with this, right? Let's say you want to delete this one, right? You see this, it says that you cannot access or you cannot open this thing on a running system because it is the system file, right? But it is possible to see and extract those details from your image file, right? That's why always will prefer imaging in the forensics, right? It will be more beneficial for us in terms of forensic analysis. Okay, right. So these are the forensic artifacts which is available in Windows operating system that we need to look when we are going to analyze Windows operating system, right? So what is Windows Registry? As we know, it is a giant database which contains information, settings, options, and other values for softwares and hardwares which are installed in all versions of Microsoft operating system, right? So Windows Registry is available in every Windows operating system, and it contains almost every detail about your system, right? Every details about user activities, whatever hardware and software installed on your system, that can be seen and identified from Windows registries, right? When you first open Windows Registry Editor, it will display certain root keys which is known as hives, right? So these are the 5 registry hives that we can see. How to open registry? Let's say you can just open regedit. You can just type regedit in your browser, and it will take you to the
No,
analysis in Windows Forensics, which contains details about computer specific information about the hardware which are installed, software settings, and other information. Information is also used by all users who is logged into the computer, right? It is not user specific. It contains details about your entire system, right? This key and its subkeys is one of the most frequently areas of registry viewed and edited by the users. HKU, that is HKey users, which contains information about all the users who logged on this system at any point of time. It contains details about user specific as well as generic information. And the
because
last,
screen not visible.
hello,
Screen not
Your
visible.
screen is not visible.
have shared it now earlier. Now is it visible?
Yes, sir.
Okay. You should have informed. Okay. Whatever. So we were discussing about Windows registries. Since how long you are not able to see my screen?
1 minute, 1 or 2 minute.
Okay. Okay. That's fine. So we were discussing about this Windows registry. So you see, these are the registry hives which is available in your Windows operating system, right? And the meaning of these registry hives we were discussing. So H key CC, or you can say H key current config. The details about current configurations of your hardware which are attached to the system is being available in this H key CC. Okay. So what is the forensic importance of this Windows registry? You see, it is a giant database which contains information about operating systems as well as it stores details about programs and settings of your program. Right. So as we discussed, registry itself are found on this path. See Windows System 32 config in the offline condition. Right. If it is in the running state, you just open regedit, you can see that. But let's say you have image file which is the offline archive, then you can look all these registry hives in this path. See Windows System 32 config. Okay. Default SAM security software and system. These are the most common and important registry hives in terms of forensics. All the registry hives are found in the same path. One auto backup of these hives is been stored in Windows regback folder in regedit. Right. You will find these hives in HKey LM. You see, in this HKLM, you will find all these registry hives, hardware, SAM, security, software, system, which is available into this path. Right, SAM, security, software, system, somewhere it will be hardware and drivers, default. All these are the hives of your HKLM. Okay. In every profile, right? Every profile means every user specific registry hives which has been named as anti-user.dat, which means HKCU in the registry, right? Which is available in this specific path. It is available in C users, username, and here you will find anti-user.dat. This registry hive is user specific registry hive, right? Let's say in your system there are 5 users and you want to know what activities has been carried out by that particular user, that can be identified using this registry hive, right? Okay. Now, what are the artifacts? I have listed a very few artifacts that we can see from the Windows registry. That is anti-user.dat, or you can say HKCU, software, Microsoft Windows, current version, and Explorer. Right. So let me just go to that path. HKCU, software, Microsoft Windows, current version, Explorer, and here you see there will be, these are the details. Run MRU, right? Run MRU means what are the programs. See, this is the run MRU. It will show me the most recently used run commands. Run commands means whatever I am typing here in run Windows R, but it will be visible in this particular path. Right, run MRU. You see, I have typed ms config and Kelsey, notepad, and so on. Right. MRU stands for most recently used. Right. Okay. Here you see it is MRU list. It is giving me this details. This is the data which says MRU list. C means it has been used recently. Right. Then we have E. E means this CMD. Before Kelsey, I have used this CMD. Before that, I have used this G. G is for regedit, and so on. Right. This is the MRU list, and these are the nomenclature given to this particular commands. Okay. Then we have recent docs. You see, these are the documents that were opened into the system, but hopefully you cannot interpret these details. Right. So to parse all these details, we can use a particular tool which is available, which is been called as let's say registry explorer, right, which has been developed by Eric Zimmerman, and widely we are using this particular tool which has been developed by Eric Zimmerman, right. Very handy tools for forensic analysis. right? Definitely, I'll recommend everyone to visit their website and look for the tools that have been developed by Eric Zimmerman. And here you can load your offline registry hive as well as you can load your online registry hive. Right. So let me just get that offline registry hive and user.dat. Let me just have this. I'll just export it on my desktop, for example. One file has been exported, and here I load that registry hive. That is ntuser.dat. Okay. So here in the root, I will have those data which I can parse. It's taking some time to get loaded. Let's just wait for that. I think. Okay. On the root, we will have software, Microsoft, Windows, current version, and we will have Explorer. Here we will have recent docs. So here you see all the documents which have been accessed by that particular user. It will be visible here, right? When you see it has been bifurcated based on the extensions, right? For example, if I want to know what are the documents that were opened, right? Oh, I hope you can see this. Let me just zoom it some. You see, these are the doc files which were accessed by this particular user, right? All sort of doc files. Let's say if I want to see what are the JPGs that were opened into the system, you see, right? This is how you will get to know what are the files. You see, these are the PDF files which were accessed by this particular user, right? Even you can see here the position is also given, right? You can just sort it accordingly, right? So this is how you will get to know what are the files which were accessed by that particular user. Okay. Even you can see typed paths. What are the paths that were typed by that particular user in the Explorer, user assist? It will give you the details about program executions by that particular user and so on. Right. Even you can see in this run key, which is available here. Okay, see, these are the keys which will run when your computer gets started, right? This registry key is mainly been tempered by malware authors, right? Basically, the files which is been executed here, it will start when your computer gets started, right? So just to make it persistent, most of the malwares are making changes into this particular keys, right? So analysis of this registry key can also be crucial. Okay. Then we have USB store, right? So this USB store will also give you the details about USB devices that were connected to the system, right? That can be seen in the HKLM, right? But for analysis of USB devices, we'll see some other tools. Okay. Then we have prefetch. Prefetch files will give you the details about the programs that were executed recently in the system, right? So to identify the prefetch, there is a tool available in NearSoft that is called as WinPrefetch View, right? So let me let me just open that particular tool. In the NearSoft, you will find whether it is 64-bit or 32-bit, and you will look for WinPrefetch View, right? So this is the tool. You will run it with the admin privileges, and it will show you all the programs that were executed by the user, whether it is user specific program or it is computer specific, right? Let's see, these are the system programs, right? We have used Magnifier recently, we have used Reg Explorer, right? Regedit we have used, FTK Imager we have used, and so on, right? All the programs that were executed by the user will be visible in this win prefetch in the running system, right? In the image, there are so many tools available to parse this prefetch details. Okay. Then we have shellbacks. See, shellbacks are those files, or you can say those artifacts. It is been stored in Windows operating system when you customize that folder. Right. For example, you customize that folder by changing the view of that folder. Right. For example, I am just changing the view of this folder from list to this tiles or icons. Right. So I am customizing this folder. So these details are been stored in shellbacks. Okay, how forensically it is important for us to identify. So let's say in external drive someone has changed some customization, then we can say that definitely this folder was opened into the system at any point of time, right? For example, we have that particular tool called shellback explorer.
मेमोरी एक्विजिशन वही सीट से फ्री टॉपिक पे
Okay, so there is a tool called shellback explorer. So you can load your registry hive, active registry hive, and you will get to know. So these are the you can say files and folders that were open in the system. You see, this is the X drive, which is external drive, right? Because if you see here, we have only D, E, F, G, but this is the X drive, which is external drive, right? So those files and folders which is opened into the system and customized is visible. It is available here in this particular system, right? So it's possible to identify the external drive content using these shellbacks. Okay. Volume shadow copy, see, it is a kind of backup, or you can say restore point, which is being created. Exactly, it is not restore point, but just to get understand, we can say it is a kind of restore point which is been created by Windows operating system, right? So to identify what are the details and what are the files and folders available into the system at a particular time, so we can use this volume shadow copy, right? So to see the volume shadow copy, there is a tool available in your Nearsoft. We can use shadow copy view tool. Right? The name of that tool is shadow copy view. You can just run it with the admin privileges. We must use 64-bit. Okay. So we can use the shadow copy view, and it will show us the volume shadow copies available in the system. You see, this is the volume shadow copy which is been created just now. So what are the details available in this system? It will be visible here, right? Then the username and desktop, let's say, what are the files and folders available into the desktop? It will be visible in the system, right? Let's say we have 3 volume shadow copies. So what are the files and folders available at that particular time? We can see this using this volume shadow copy, right? Before 1 week or before 1 month, what are the files available into the system? We can see that using this volume shadow copy. USB devices, see, these are the registry keys by which we can identify USB devices manually. Or else, there is another tool called USB DView. The tool named is USB DView, which is available in Nearsoft package only, by which you can get to know what are the USB devices that are connected to the system, right? So you see, it has USB device name, descriptions, the device type, whether it is currently connected or not, whether it is disabled or not, what are the serial numbers. See, this is the unique identification of that particular USB device. Right? Created means when it is first plugged in. Right? Creation means when it is first plugged in, and last plug-in is when it was last plugged in. Bid and PID, this is the vendor ID and product ID, and all the details have been given here. Right? You can just look at here. So at any point of time, if any USB device has been connected, you can see it here, right? There is another tool that we can use is USB detective, right? But to use USB detective, you must have certain registry files, right, that you have to extract from FTK imager, right? But because of time constraint, I'm not going to show it to you. So you can select files and folders, you see you must have system hive, software hive, anti-user.net hive, setup API in amcache.hive. You can just add those hives respectively, and you can just click on process artifacts, and it will show you all the details of your registry files, USB devices, right? And how to get those files, it is also been written here, right? Setup API will be available in C Windows setup API, and your amcache.hive will be available into this path. Okay. Link files are those shortcut files which has been created when you access a particular file, right? For example, you are accessing that let's say Excel file, then you deleted that file, but still that shortcut file or link file has been there, right? So by analyzing that link file, you can get to know which file was available, what is the timestamp of that particular file, original file, what are the attributes, and everything can be possible to analyze it using link files, right? So it is available onto this path. See users, username, app data, roaming. Let me show it to you. See users, username, app data, roaming, Microsoft Windows, and recent items, right? So you see these all are the shortcut files, right? Let me just click on show extension. You see these are the recent files which has been accessed by that particular file, particular system, right? Particular user. You see these are the shortcut files. These are not actual files, right? You see these are the shortcut files. Now if you see the properties of that file, right, if you see the properties, you will see the details of that particular file, when it was created, when it was modified, and so on. All the metadata related to the original file is been stored in these link files. Okay. Then we have jump lists. In a very general manner, what does jump list means? You see, when I right click on a particular tool, a particular application, it will show me what are the files that were accessed recently in this application. For example, in PowerPoint, I have opened this much of files recently. Right? In, let's say, in registry, or we can say in the Google Chrome, these are the we can say websites that were opened recently on this. Right? If I click on this file explorer, right click, these are the files and folders that were opened recently, right? So these details have been stored in jump lists. Okay, I'm not going to show you practically due to some time constraint. Timestamp analysis, it can be very much crucial. You see, there is an anti-forensic technique called timestamp, by which you can just temper the timestamp of original file. Okay, now our target is to identify whether the data has been tempered or not. After that, what is the original timestamp, right? So in the MFT stands for master file table, which contains two timestamps. One is standard information, second one is file name, $SI and $FN, right? So $SI can be changed using timestamp, but $FN is kernel level data which cannot be modified by any user, right? So by just comparing the timestamp of $FN and $SI, you can get to know what is the original timestamp of that particular device, a particular file. MFT, so as we discussed, MFT is master file table. Every volume will have its own MFT, and it will contain details about your files and folders of that particular volume. Also, it will contain details about metadata of that particular files and folders. AM cache and shim cache, these both are the artifacts that can be used for identifying the program execution in the system, right? Basically, it is also called as application compatibility cache, right? If there is an application compatibility issues, for example, you are using 32-bit architecture software in 64-bit, right? So there is an application compatibility issue. So that has been cached and stored in AM cache and shim cache. So that can also be used to identify the program execution and get to know what are the programs that were executed into this particular system that can be identified using AM cache and shim cache. Right. So I hope this is informative to you. I hope you understand a very basic understanding of Windows artifacts that can be available in our Windows operating system. It may possible that due to some time constraint, I might be little fast, but I hope it is understandable to you. It's that's it from my side. If you have any questions, I'll be more than happy to answer.
Sir, actually, I have a question.
Yes.
Sir, normally, can I speak in Hindi? Because I am not. तो डाउट ये है कि जैसे कि हम लोग पेन ड्राइव ले लो फॉर एग्जांपल के तौर पे, हम लोग समझ में नहीं, एक फोल्डर बनाया, उस पर डॉक्यूमेंट्स डाला, और आपको भी मालूम है मतलब एज टाइम पासिस मतलब जो उसका पॉइंटर हटता है, मतलब जैसे कि क्या बोलते हैं उसको, हाँ, मतलब वो डॉक्यूमेंट का मतलब डिलीट किया मैंने, वो फोल्डर ही डिलीट किया, जब तक उसका जगह में और कोई फोल्डर नहीं आता तो वैसा का वैसा रहता ना, तो उसका जगह में वो दूसरा डॉक्यूमेंट आ गया तो उसका वो हट जाता ना, तो वो रिकवर कर सकते हैं क्या फॉरेंसिक में?
See, a very basic thumb rule of data recovery says overwritten data cannot be recovered. ठीक
नहीं
है, अगर
फॉरेंसिक में।
जहाँ कहीं भी नहीं हो सकता है, ठीक है, ये फॉरेंसिकली या तो कोई भी टेक्निक से आप ओवररिटन डेटा को रिकवर नहीं कर सकते, दैट इज थंब रूल। ठीक है, अगर आपका डेटा जो है, मान लो एक सेक्टर नंबर 178, तीन अलग अलग सेक्टर्स बेसिकली क्लस्टर्स में है वो डेटा, ठीक है, तो अगर वो क्लस्टर्स ओवरराइट हो गए हैं तो उसके नीचे का डेटा आप रिकवर नहीं कर सकते, और अगर वो रिकवर हो पा रहा है इट मींस इट इज नॉट ओवर रिटर्न। ठीक है ना, तो आप ओवर रिटर्न डेटा को कभी भी रिकवर नहीं कर सकते, दैट इज द रीजन when you are going to wipe your hard drive, what does wiping mean? It will wipe and it will overwrite your entire device with random zeros and random one, right? Because normal deletion and normal formatting of your hard drive or pen drive can recover the original data, but if you wipe out, what does wiping will do? It will overwrite every clusters of your hard drive with random zeros, so that previous data cannot be recovered, right?
अगर कोई क्रिमिनल ऐसे किया तो फॉरेंसिक वाले को और मुश्किल पड़ेगा ना, उसका
हाँ,
कुछ
definitely.
सॉल्यूशन ऐसे कुछ अभी तक आया है?
ओवर रिटर्न डेटा को नहीं रिकवर कर सकते, देयर इज नो वे एज फार एज माय नॉलेज इज कंसर्न।
और ये डिजिटल फॉरेंसिक हम लोग को पूरा फॉरेंसिक का सेक्शन सीखना पड़ता है या उसका अलग अलग होता है? मतलब जैसे कि आईटी में क्या है कि सिक्योरिटी इंजीनियर, नेटवर्क इंजीनियर आते हैं ना, वैसा डिजिटल फॉरेंसिक अलग से सीखना पड़ता है या पूरा फॉरेंसिक सीखना पड़ेगा?
सी, आप आईटी बैकग्राउंड से होते हुए भी डिजिटल फोरेंसिक सीख सकते हो, और फोरेंसिक बैकग्राउंड से भी डिजिटल फोरेंसिक सीख सकते हो, ऐसा कुछ नहीं, बट डिजिटल फोरेंसिक इज अ सेपरेट ब्रांच। ओके, एनीवन एल्स? Okay, if no one has any doubts, I think I'll just wind up this session.
Okay, hello. I hope I'm audible to you all. Hello, can you hear me, guys?
Yes, you are audible.
Okay, yeah, thank you so much. Yeah, sorry for the inconvenience. I was a bit late due to some technical glitch over here. So I would like to thank our today's host for giving such immense knowledge to all the interested candidates, and I hope it will be very, beneficial for all of us, and somewhere it will help you to grow up in the future. And thank you for attending the webinar and getting something out of it. It is definitely gonna be an it's definitely an amazing session to grow, to get into that domain and explore throughout. So on behalf of entire GC's council, I thank today's host, and I thank the founder of GCS Council, Vishal sir, for organizing such webinar and helping out the interested ones to get to know the things in a better way. Okay, thank you for joining. Thank you, everyone.